Welcome to problem solving in Algebra and Geometry, page 28. Really just two quick things here to help with page 28. It shouldn't be too bad. One, just a little review for finding the equation between 2 points. We talked about this in the last video, so it should be some good review. But again, I want to impress upon you the beauty of point-slope form and how it makes your life much easier. If we're given 2 points, I do need to find the slope. So first I'll find the slope. Change in y with a change in x. Doesn't matter which way I go, right? I could do this minus this and this minus this, or the opposite way, as long as I go in the same direction. So let's do the change in y as 2 minus negative 3. Remember, 2 minus negative 3 going to wind up being positive 5, because minus negative is positive. Then we got 4 minus 7, so I think that should be negative 3. So there's my slope. But remember, the beauty is I know point-slope form. Point-slope form, y minus y1 equals m times x minus x1, where that's the slope, and x1, y1 are our point. Let's use this point. My y is negative 3. Well, y minus negative 3, don't forget the minus that's inherent in the formula, plus the minus of the point, equals our slope of negative 5/3 times x minus 7. And actually, you're finished. That is the equation of a line. Right? If you wanted to make that into a positive, you could. You could say y plus 3 equals negative 5/3 times x minus 7. If you wanted to distribute this 5/3 over both and subtract the 3, you'd just be turning it into slope-intercept form, which is fine, but notice those are two totally equivalent equations. If the question is, find an equation for this line, you've done it here. This is a totally valid equation for that line. Finished. Now, if you wanted to graph it on your calculator, and you just had the TI-84 and you weren't using Desmos the way you probably should, obviously you do need to solve this for y. But that's okay. You would just subtract the 3 from both sides, and you could plug this into your calculator just the way it is with the parentheses, and it would graph the line. So again, really easy. Practice a little bit. Get used to point-slope form. It will definitely make your life much better. Final thing I want to talk about is I want to revisit absolute value again. So in the last lecture video, we talked about the fact that that means, right, the question that mathematical notation is asking is how far is x from 0? So that's why we talked about the absolute value of 5 is 5, because 5 is clearly 5 away from 0. Absolute value of negative 4 is 4, because negative 4 is 4 away from 0 on a number line. But what about this? Let's think about what that question is asking. It's a little trickier. Let's plug in some numbers and see what we get. So I'm going to plug in some numbers for x, and then we're going to figure out what this thing is. What if x is 0? If x is 0, I plug that in. 0 minus 2 is negative 2. The distance that negative 2 is from 0 should be 2. Okay. And if x is 1, 1 minus 2 is negative 1. Absolute value of negative 1 is 1. Try 2. 2 minus 2 is 0. Absolute value of 0 is 0. How about 3? 3 minus 2 is 1. Absolute value of 1 is 1. We should try some negative numbers. Let's go to negative 1. Negative 1 minus 2 is negative 3. Absolute value of that is 3. So this is a little interesting here. So when I plug in 0, I get an answer of 2. When I plug in 1, I get an absolute value of 1. This is actually a pretty interesting place to look at. When x is 2, the answer to this question was 0. Hit pause, look at this table for a couple minutes, and see if you can figure out what is happening here. I see that you're back. I hope you managed to figure this out. If you look at it, when x is 2, if this thing is 0, it still means a distance. But this no longer means the distance that x is from 0. It actually means the distance that x is from 2. Because notice if I plug in 2, how far is 2 from 2? Well, I think it's 0 from 2. How far is 1 from 2? Well, that's 1 away. How far is 0 from 2? It's 2 away. How far is 3 from 2? Back to 1 away. How far is negative 1 from 2? Well, that's 3 away. And if you look at it up here, this actually we could have written as x minus 0. which would be consistent. This really means how far is x from 0. In the same way this means how far is x from 2. So clearly this would mean how far is x from 5. Now let's take something like 10, right? If x is 10, well, I'm pretty sure that 10 is 5 away from 5. Let's see if that works out. Plug 10 into here. 10 minus 5 is 5. Absolute value of 5 is 5. Nice. What if x was negative 2? When I think in my head, negative 2 from 5, I'm pretty sure that's 7 away. Let's see if it works. Plug in negative 2. Negative 2 minus 5, negative 7. Absolute value of negative 7 is 7. Oh my goodness, that's pretty amazing. What if what would that mean then? You might think that means the distance that x is from 2, but that doesn't make a whole lot of sense because we just agreed that this means the distance x is from 2. But think about that for a second. That probably means, because this minus, right, I could rewrite this as x minus negative 2, which is now in the same format. So it looks like this probably means how far is x from negative 2. Let's double check. So again, I'm just going to make a nice little table here. Let's see, if x is negative 2, here I do negative 2 plus 2, which is 0. Absolute value of 0 is 0. I think that's good. Negative 2 is 0 from negative 2. How about 4? Well, if we're saying this is the distance from negative 2, I'm pretty sure that 4 is 6 from negative 2. 4 plus 2 is 6. Absolute value is 6. Oh, let's do one more. How about negative 7? Well, I think the distance that negative 7 is from negative 2 should be 5. Let's check it out. Negative 7 plus 2, negative 5. Absolute value of negative 5 is 5. Nice. So again, right, it's obviously once we started talking about variables, your idea of, oh, just make that positive, it's negative, or negative is positive, doesn't work at all anymore. So make sure you really understand what the definition of absolute value is and can use it nicely. Have fun with page 28, and we'll see you tomorrow.